Hey everyone, in this video, I quickly want to go over the Isotopes Lab. So for this lab, you are going to be obtaining a sample of the hypothetical element. So ours is going to be the beanbag element. So we'll call it beanbag or BG for short. And we're going to determine the number of isotopes of the element based on the appearance. Okay, so if you scroll down here, I've already done this for you. So the first one is going to be black beans, the next one's going to be yellow beans, and then we have green beans or round beans. All right, then count the total number of atoms. All right, and then count the number of atoms for each isotope recorded in the data table. So I have already done this for you. So there's 202 black beans, 81 yellow beans, and then there's 73 green or round beans. And if you can't see the numbers too clearly, I'll also put them here in red for you as well. So what you're going to do is down here in your data table where it says number of atoms, so isotope 1, you got to decide which one you want to be 1. So if you want it to be the black beans, then you would type in right here 202. And then the mass of the atoms, I went ahead and took pictures of what these weighed on the balance for you. So for example, for the black beans, this would be 67.84 grams. So you would come down here and you would put your 67.84 grams. Okay, and you would do that for the other two as well. Okay, then the next part is to determine the average mass of each isotope to 3 significant figures. So enter the results in the results table, and this is the equation that you would use. So you would take the mass of atoms, divide it by the number of atoms. And so what that means is, for example, here, this would be 67 divided by 202. And then that would give you the average mass. And so you would put that average mass right here. So for example, again, if I go to my calculator and I do this 67.84 and I divide it by 202, then I should get 0.336 in grams. Okay, and again, you're doing 3 significant figures there. Okay, and you're going to do that for all 3 of these. So you would do that for the other 2. Then, what's the total number of atoms in the original sample? And we're going to calculate the percent abundance of each isotope. So to find the total number of atoms, you would take and you would add this 202. So 202 plus 81 plus 73. Whenever you do that, you should get 356. So that should be your total number of atoms. Again, 202 plus 81 plus 73, 356. That's your total number of atoms. And then to find your percent abundance, you're going to take the number of atoms for each isotope and divide that by the total number of atoms. And so what that means, and then times it by 100. And so what that means is, for example, for this right here, okay, you would do 202 divided by 356 and then times it by 100. So you should get this 56.74%. Okay, that would be your percent abundance for the black beans. All right, then to find the atomic mass or the average atomic mass of the bean element, you would go through and you would then take your percent abundance and turn it into the fractional abundance. So that's where you take this number here and you either move your decimal 2 places to the left or you're going to divide by 100. I don't care, whichever way works best for you. And then you're going to times that by the mass of the isotope. And so, for example, the mass of the isotope that it's referring to is going to be this average mass right here. Okay, so average mass of your isotope. All right, and so for example, for this first one, this is where you would have 0.5674 times 0.336 grams. So you're going to be using this results table to calculate what your average atomic mass would be. Okay, and make sure that when you are doing your calculations for all of these, that you are first off showing all steps. So I need to see every step that you use to solve these problems. So that doesn't mean just write the answer. That doesn't mean try and cut corners. That means show me all the steps that you use to solve for each, for example, the average mass or for the percent abundance, all those things. Okay. Then you also have this question, the isotopes of magnesium are, and then Mg24, and that's 79.0%, Mg25, 10.0%, and Mg26, 11.0%. So you're going to calculate the average atomic mass of magnesium. So that's this, where you're doing the fractional abundance times the mass. Okay. And so also here, the mass of an atom. So if it says 24, that's really 24.0. This would really be 25.0 and 26.0. Okay. And then don't forget to take your percentage, take it out of the percent. The next two questions are going to be research questions. So this one right here is about mass spectrometry. All right. So you are going to research. That means you are going to Google or look up what mass spectrometry is, and then give me two applications of this technology in forensic analysis. And so I've given you two websites that are really good to use to find information about this. And I need at least 5 sentences on your separate sheet of paper. And then the next one is about something called heavy water. I don't know if you've ever heard of heavy water or not, but you're going to research it. So in 5 sentences, you're going to tell me what heavy water is and what it is used for. And you're going to write that on your separate sheet of paper. And then here, down here, is where you're going to actually insert the picture of all of your calculations. So all the calculations that you did here, that you did in your results table, how you figured out the mass of the atoms, okay, all of that is going to be, well, how you found out the average mass, okay? All that is going to be on your separate sheet of paper that you're going to take a picture of and insert here, okay? So if you have any questions about the calculations for this lab, what you need to do, please send me an email. But again, here's where you find the mass of the atoms, and then here's where you find the number of atoms as well. All right, so if you have any questions again, then please send me an email.